So in the last video, we have seen the knowledge-based systems, where the components of knowledge-based agents or the complete repository of information, which is a knowledge base, and the inference system, how this inference is getting updates for the new data from the user, and how it is making decisions, how it is doing processing externally, and it come out with a decision or kind of planning. So there is a famous example that we have seen in the last video about the Wumbus world. So a 4 cross 4 cave where the knowledge is inculcated into the agent. There are a set of actions that will be performed by an agent using some sensors by learning the environment and how it is uh, deducing information from the environment, and it come out with a conclusion, what kind of action it has to perform based on the environment. The second kind of representation is the semantic network representation. So these can be represented, the knowledge can be represented using semantic network also. So an alternative way of proportional or a predicate logic for the representation of knowledge. Here, the knowledge are represented in the form of graphical network. So it's a kind of a visual based system where every nodes play a different kind of characters, different kind of subsystems. It is also very easy to deduce information if you have a visual kind of a system. So it consists of nodes representing objects and arcs, which describes the relation between those objects. So these networks can categorize the object in different forms, and it can also link to those objects. So as I already mentioned, it is very easy to understand and can be extended. So the relations can be used in semantic network or is a relation and a kind of a relation. So there are interconnecting points, and there is a line which connects all the nodes. It's most popular in AI and NLP because it reduces represent knowledge and support for reasoning. This is a simple example using semantic network representation. Here, if you look at each and every points, they are all the nodes categorizing the characters. So this one, Jerry. Now, if you take this node, Jerry, this guy, it is a cat. Now, from this diagram, we can deduce that it is a cat, and cat belongs to mammal, and mammal comes in animal family. So, for each of these nodes, there is a relation. Is a relation is there, and this Jerry is owned by Priya, and it is white in color. So, some of the attributes that we can represent for this character is kind of the relations. So by looking at this diagram, how you data, capture data, and how internally this data gets stored. And if you use an representation, the easy way of representation, and whenever there is a query comes from the users, it is very easy to just interpret what is this information, and you can just broken down into tokens, and you can check the processing at the back end and how what kind of manipulations to be done. Based on that, the output will be delivered successfully with the correct response. So these are all different symbols which connects using a relation is a relation, and it is very easy and convenient to represent and efficient way of categorizing the data and retrieval process. So they are majorly used for the data representation, which reveals structures about the relations, proximity, and the importance. And it also supports for navigation and conceptual addition. So an alternative way of semantic representation, there is one more representation for knowledge that is called as a frame representation. It's nothing but it's a record-like structure which consists of the collection of attributes and the corresponding values to describe what is an entity in the world. So basically, it's like a table where you have a lot of or a collection of slots and the corresponding values. The slots can be of every different types and sizes. We call these slots with names and values as visits. So any number of slots can be there for a frame, and a value can be associated for a slot, and it represents knowledge, uh, similar to how you categorize data in a form of a table. And this example of book representation using frame structures, where you have different slots and the possible attributes of the books is the title of the book, who is the author, and edition, year of publication, page number, and these are all the value associated with every slots. So no number of slots and the corresponding values, and this gets updated for each and every book. So this is one record structure or the structure of a book. The second example is about a person, employee. What is the name of an employee and what is the profession? What is the age, status, city? This could be applied as a kind of a frame representation. So with this, we complete the different types of knowledge representation using semantic and frame representation. Thank you all.